Walk down any tea aisle, and you will see an overwhelming variety of colors: green, black, white, and oolong. The marketing suggests these are completely different plants with different biological properties. This is a botanical myth. All true tea comes from the exact same evergreen shrub, Camellia sinensis. The difference between a cup of delicate green tea and robust black tea is not agricultural. It is a controlled chemical reaction. Today we map out the oxidation of tea and how it fundamentally alters the molecules you ingest. When a tea leaf is plucked, it is packed with a specific class of polyphenols called catechins. The most potent and clinically studied of these is EGCG, epigallocatechin gallate. EGCG is an incredibly powerful antioxidant linked to reduced cellular damage, improved cardiovascular health, and slight metabolic thermogenesis, fat burning. To make green tea, producers must preserve these catechins. Immediately after picking, the leaves are blasted with heat, either steamed or pan-fired. This intense heat permanently denatures the enzymes inside the leaf, freezing its chemical state. The leaf stays green, and the EGCG remains perfectly intact. Black tea is subjected to the exact opposite process. The leaves are picked and intentionally crushed or rolled to break the cellular walls. They are then left in a climate-controlled room to oxidize. When the cell walls break, an enzyme called polyphenol oxidase mixes with oxygen in the air. This enzyme aggressively attacks the green catechins, forcing them to bond together into much larger, heavier, darker molecules called theaflavins and thiorubigens. This is the exact same chemical reaction that causes a sliced apple to turn brown on your counter. The green tea has effectively been chemically rusted into black tea. So, which is healthier? It depends on your biological goal. When the catechins are converted into theaflavins, the tea loses its potent EGCG antioxidant power. However, it gains a new superpower. Because theaflavins are massive, complex molecules, your small intestine struggles to absorb them. They travel largely intact down into your colon. Clinical data now suggests these large theaflavins act as powerful prebiotics. They selectively feed specific strains of beneficial gut bacteria, promoting the production of short-chain fatty acids. Green tea protects your cells. Black tea feeds your microbiome. Finally, we must address the brewing chemistry. If you hate green tea because it tastes like bitter grass, you are brewing it wrong. The delicate catechins and amino acids, like L-theanine, in green tea are highly sensitive to thermal stress. If you pour boiling water 100 degrees over green tea leaves, you physically scorch the polyphenols and extract bitter tannins at a highly accelerated rate. Black tea requires boiling water to extract the heavy theaflavins. Green tea requires water around 75 degrees to 80 degrees. If you use the right solvent temperature, the chemistry yields a sweet umami profile. Tea is an exercise in applied chemistry. By understanding the oxidation gradient, you can choose exactly which molecular profile you want to ingest.